Hello students, how are you? I hope all of you are good. So today I am going to discuss the concept of integration by substitution method, and in that I am going to discuss some of the questions which are asked in your previous year annual examinations. So without wasting the time, let's start the concept. What is the concept here? Integration by substitution. So firstly, I would like to discuss when we are going to use this substitution method. So which type of integral problems are going to solve by using this substitution method? So let's start the concept. See here, as you know that, as you know that, if we have integration of the function fx, the function fx with respect to x. So in this integral problem, this is nothing but your integral sign. This is what? Integral sign. And what is this? So this is one of the variable of integration. What is dx? Dx is nothing but variable integration, or variable of integration. Variable of integration. And see here, fx, the function which is going to integrate, the function which is going to integrate, that is called as integrand. It is considered as what? Integrand. So if in any integral problem, if in any integral problem, the integrand includes with, or integrand involves with a function and its derivative, a function and its derivative, then we use what? Integration by the substitution method. I hope all of you understanding. So let us discuss briefly about it. See here, if suppose we have a integral problem such that, see here, if we need to integrate a function, so integration of fx and its derivative f dash x with respect to x. So see the integrand here. What is integrand here? Integrand is fx and its derivative. So if in any integral problem, if we have an integrand with a function and its derivative, then we are going to use such type of integral problems by using what? Substitution method. See here, if we have a integral problem which consists the integrand with function and its derivative, in such type of integral problems, we need to substitute. We need to substitute this function. What is the function here? Fx. Here we need to substitute this function with another variable t. If I substitute the function fx t, we need to integrate with respect to x. That's why we need to differentiate this function. We need to differentiate this function with respect to x. Differentiate with respect to x. And we know that derivative of fx with respect to x is f dash x, and t with respect to x is dt by x. After that, and by cross multiplication method, it can be expressed as f dash x into dx is equals to what? Dt. Now by this substitution, integral problem, let's say this is equals to I, integral problem I becomes, see here, integration of, we considered fx is equals to t, therefore t, and then we obtained f dash x dx is equals to dt, therefore in place of f dash x dx is dt. Now we can easily integrate this problem. Now we can easily integrate this problem by using what? By using standard integral problems, standard integral or integration formulas. I hope all of you understood the concept. Now let us consider some examples. Firstly, I am going to consider some of the very easiest examples. So in which type of functions we are going to use the substitution method, the integral problems in which the integrand consists both function and as well its derivative. So here let us consider one of the example. Evaluate I equal to integration of tan x into secant square x dx. Integrate I equal to integration of what? Tan x into secant square x dx. So observe the integrand here, tan x into secant square x, and we know that the derivative of tan x is, we know that the derivative of tan x is secant square x. Therefore, this integrand consists tan x and its derivative. So it means this integral problem definitely solved by using what? Substitution method. By using substitution method. So here I am going to consider the function. What is the function here? Fx, that is what? Tan x. So here I am going to substitute what? Tan x is equals to t. Put tan x equals to t. And we need to integrate with respect to x. Therefore, differentiate this with respect to x. We know that the derivative of tan x is, the derivative of tan x is secant square x equals to t with respect to x is dt by dx. I hope all of you understanding. By cross multiplication, finally we have secant square x into dx is equals to what? Dt. So therefore, by using this substitution, integral problem I equal to integration of, we considered tan x equals to t. So t, we obtained secant square x dx is equals to dt. So t dt. I hope all of you understanding. Now, sir, we can easily integrate this integral problem by using the standard formula. That is what? If we have integration of x power n into dx, and its formula is already we known. That is what? X power n plus 1 divides n plus 1 plus c. Therefore, integration of t dt is equals to, integration of t dt is equals to, let's say integration of t power 1 dt. Therefore, I equal to integration of t power 1 is t power 1 plus 1 2 divided by 1 plus 1 2 plus integral constant c. I hope all of you understanding. And let's see here what we substitute the t in the beginning. We substitute t is what? Tan x. Therefore, in answer also we need to replace that t by using the tan x. Therefore, I is equals to, therefore, I is equals to, see here, the final answer for the given integral problem is I is equal to t square, means tan x whole square divided by 2 plus c, or it can also be expressed as I equal to tan square x divided by 2 plus. I hope all of you understood. So let us consider one more example. Let us consider one more example and then we go to the previous year questions. So evaluate. Now the second question is what? Evaluate I equal to integration of 2x divides x square plus 1, 2x divides x square plus 1 with respect to x. Now observe the integrand here. What is the integrand here? 2x divided by x square plus 1. So observe here, the derivative of this x square plus 1 is equal to 2x. So it means this integrand consists function as well as its derivative. So what is the function here? Function is x square plus 1 and its derivative is 2x. Therefore, it can be solved by using what? Substitution method. And firstly, we need to consider the function, that is what? X square plus 1 is some other variable, that is what? T. So here I am going to substitute what? X square plus 1 is equals to t. So again, differentiate with respect to x. And we know that the derivative of x square is 2x plus derivative of 1 is 0, which is equals to t with respect to x is dt by dx. Again, by using the cross multiplication, 2x dx is equals to what? Dt. I hope all of you understood. So now by using this substitution, we got I equal to integration of here 2x dx is what? Dt, and 1 divided by x square plus 1. What is x square plus 1? X square plus 1 is t. I hope all of you understanding. And also we know that one of the standard integral formula, that is what? If we have integration of 1 by x dx, it is equal to what? Log of modulus x plus c. So therefore by using this standard formula, by using this standard formula, by using this standard formula, I is equal to, see here, I is equals to integration of 1 by t is log modulus t plus c. And again at last we need to replace t, that is what? Log of, what is t? T is x square plus 1 plus c. I hope all of you understood the concept of substitution method to solve the integral problems. So let us consider some of the previous year asked questions, and these questions are most important. So let's start the first question. Let's start the first question. Evaluate I is equals to, evaluate I is equals to integration of sin x into sin of cos x dx, sin of cos x dx. And this question is asked in July 2014. This question asked in July 2014. So see the integrand here. First we need to observe what? Integrand. What is the integrand here? Sin x into sin of cos t. Now observe here, we know that derivative of sin x is cos x, and also we know that derivative of cos x is minus sin x. So minus we can take outside the integral sign because it is a constant. So see here, so it means here we need to substitute whether sin x or cos x. So one more thing here, when we are use the substitution in the integral problem, we need to observe one more thing here. See the first question here, when our second question here, when we substitute the function, its derivative completely vanishes. So in first question also you observe here, if I substitute the function, that is what? Tan x, the second function completely vanishes. So it means we need to use the substitution such that the second function completely vanishes. So it means, so trick when we are using the substitution method is always try to take the substitution, the functions which are in composite form. Always try to take the substitution for which type of functions? The functions which are in composite form, or the functions under square root, or the functions whose power is in rational form. The functions whose power in rational form. For this type of functions only we need to substitute. Why? Because by substituting one function we need to vanish the second function. If I substitute the function sin x here, the cos x dx cannot vanish here because cos x in the angle form. But if I substitute the cos x here, the derivative of cos x in the form of sin form, so sin x dx completely vanish here. I hope all of you understood what I am saying here. When we are substituting, we need to take the functions which are in, or we need to consider the functions, The functions which are in composite form are the functions under square root, are the functions whose power in rational form. So here the cos x in composite form, that's why I am going to substitute cos x here. See here, I am substituting here cos x. Put cos x is equals to t. So differentiate with respect to x. Therefore, derivative of cos x is minus sin x equal to what? Dt by dx. So by cross multiplying, minus sin x dx is equals to what? Dt. But the question consists only sin x dx, but we have here minus sin x dx. That's why shift this minus 1 towards right side. It becomes what? Sin x dx is equals to what? Minus dt. I hope all of you understood. By using this substitution integral problem, I equal to integration of CL. Sin of cos x means t. So sin t. So after this, still we remain here sin x dx. We know the value of sin x dx by using this substitution is what? Minus dt. I hope all of you understanding. What next? What next? See, observe here. Observe here. From this integral problem, I can take this minus 1 outside the integral sign. Therefore, I equal to minus of integration of sin t dt. Sin t dt. I hope all of you understanding. And do you know one of the standard integration formula? Minus, as it is, integration of sin t dt is minus cos t plus integral constant c, and finally I equals to minus into minus plus cos. What is t? T is what? Cos x. Therefore cos of cos x plus c. I hope all of you understood, and this is the final answer for the given integral problem. So now let us consider the second example here. Now the second example, which is asked in your previous year examination, and the question is evaluate or integrate I, that is what? Cos 6x into square root of 1 plus sin 6x. 1 plus sin 6x with respect to x. So this question is asked in July 2018. This question asked in July 2018. So now observe here, the derivative of sin 6x is cos 6x, or you may observe here the derivative of cos 6x is minus sin of 6x, and then 6x derivative 6. But if I substitute cos x, this sign cannot completely vanish here because it is under square root. So to vanish the second function, we need to substitute the function which is under square root. So that's why we need to substitute the function under square root. Here the function under square root is 1 plus sin 6x. So that's why put 1 plus sin 6x is equals to t. I hope all of you understanding. Again same thing, differentiate this with respect to x. So we know that the derivative of 1 is 0 plus derivative of sin 6x is cos 6x. Derivative of sin 6x is cos 6x, and then derivative of 6x is 6. So finally we get 6 cos 6x is equals to t with respect to x is dt by dx. I hope all of you understanding. So therefore, on cross multiplying, we have cos 6x dx in the question. Therefore, we need to shift 6 towards the right side and dx towards the left side. So by this, we got cos 6x into dx is equals to dt divides 6. I hope all of you understanding. Therefore, by using this substitution, the integral problem I equal to integration of square root of 1 plus sin 6x is t. So square root of t into the value of cos 6x dx. So cos 6x dx is equals to what? dt divided by 6. I hope all of you understanding. Therefore, I is equals to integration of root t can be written as t power 1 by 2 into dt, and 1 by 6 is constant taken outside the integral. I hope all of you understanding. Again, by using the same formula which is used in the first formula, first problem, that is what? Integration of x power n dx. Now by using what? Integration of x power n dx, that is what? I is equals to 1 by 6 into integration of t power 1 by 2 is t power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus integral constant c. I hope all of you understanding. Therefore, I is equals to 1 by 6 into t power 1 by 2 plus 1 is 3 by 2 divides 1 by 2 plus 1 is 3 by 2 plus c plus c. Therefore, I equal to 1 by 6 into, so shift this 3 by 2 towards numerator. It becomes what? 2 by 3. It becomes 2 by 3 into t power 3 by 2. I hope all of you understanding, plus integral constant c. Now observe here. Now I can cancel here. 2 ones are 2 threes are. Therefore, I equals to 1 divided by 3 into 3 is 9. And what is t? So t is what? 1 plus sine 6x. So 1 plus sine 6x power 3 by 2 plus integral constant c. I hope all of you understood. Now let us consider one more example which is asked in your previous year annual exam. Let's start what? Third question. Evaluate I equal to integration of tan power 4 root x into secant square root x into secant square root x divided by root x dx. And this question is asked in March 2017. This question asked in March 2017. See here, observe the integrand again here. The integrand used in this integral problem is tan raised to 4 root x into secant square root x divided by root x. So we know that the derivative of tan is secant square x, and the derivative of root x is 1 divided by 2 root x. Therefore, definitely the derivative of tan root x is secant square root x divided by root x form. So it means I need to substitute tan root x here. In madati nodri, put what? Tan root x equals to t. Now again same thing, differentiate with respect to x. Differentiate with respect to x. Derivative of tan root x is secant square root x into derivative of root x is 1 divided by 2 root x equal to t with respect to x is dt by dx. So therefore it can be expressed as secant square root x into 1 is secant square root x divided by 2 root x equals to what? Dt by dx. So if I substitute this, remains in the integrand secant square root x divided by root x. Therefore, shift this 2 towards the right side and dx towards the left side. So it means we have what? Secant square root x divided by root x dx towards left side equals to 2 towards right side, that is what? 2dt. I hope all of you understanding. Now by using this substitution, the integral I becomes, so integral I is equals to, integration of tan raised to 4 root x. T is tan root x, its power 4. That is what? T power 4 into, remains in the integrand, secant square root x divided by root x dx. So secant square root x divided by root x dx is equals to what? 2 dt. So 2 dt. I hope all of you understanding. Now 2 is constant taken outside the integral. I equals to 2 into integration of t power 4 dt. By using the same standard integral problem, integration of x power n. So 2 into t power 4 plus 1 divides 4 plus 1 plus integral constant c. I hope all of you understanding. Therefore, I equals to 2 into t power 5 divided by 5 plus c, or I is equals to 2 by 5 into what is t? T is what? Tan root x. So tan root x power 5 plus integral constant c. Or it can also be expressed as, the value of I is equals to 2 by 5 into tan raised to 5 root x. Tan raised to 5 root x plus c. Tan raised to 5 root x plus c. And this is the final answer for the given integral problem. I hope all of you understanding. Now let us consider one more example. Evaluate I is equals to integration of log sin x into cot x dx. And this question is asked in March 2020 as well as in March 2025. March 2025. So year ಕೇಳ್ಯಾರ ನೋಡ್ರಿ. See here. Again observe the integrand here. The integrand is log sin x into cot x dx. So the derivative of cot x, we know derivative of cot x is minus cosecant square x. But here the other function is log sin x. So let us use the substitution for log sin x. See here, log sin x na substitute ಮಾಡಿದ್ರೆ ನೋಡ್ರಿ cot x ಬರುತ್ತಿಲ್ಲ. So I am using substitution for log sin x. So put log sin x is equals to t. So same thing, differentiate with respect to x. Derivative of log sin x is 1 divided by sin x, and then derivative of sin x is cos x, which is equals to t with respect to x is dt by dx. See here, we know that cos x by sin x is cot x is equals to what? Dt by dx. Again by cross multiplication, cot x dx is equals to what? Dt. So finally we got the second function, that is what? Cot x. Now by using this substitution, the integral I is equals to integration of, see here, log sin x is t. So remains cot x dx, and we have cot x dx is equals to what? Dt. So t dt. So now we can easily integrate this by using the standard formula, integration of x power n. So therefore integration of x power n is t power, or integration of t power 1 is t power 1 plus 1 divided by 1 plus 1 plus c. Therefore, I is equals to t square divided by 2 plus c. Again, we need to replace t by the log sin x, because therefore I is equals to log sin x power 2 divided by 2 plus c. I hope all of you understood. Now let us consider the one more example. Evaluate I is equals to integration of 1 divided by x minus root x dx. 1 divided by x minus root x dx, and this question is asked in March 2015. This question asked in March 2015. This question asked in March 2015. First we need to simplify to get the substitution formula. We know that integration of 1 divided by x can be written as root x whole square ಬರ್ಕೋಬಹುದು ನಾನು. Square root and square get cancelled, again same thing. So there is no difference between these two. So x can be replaced by root x whole square minus what? Root x with respect to x. Now observe here, I equals to integration of 1 divided by, in denominator I can take root x as common. If I take root x as common, remaining in the first term root x minus in second term 1 with respect to x. Now observe the integrand here. We have 1 by root x and 1 by root x minus 1. So if I substitute this root x minus 1 equals to t, its derivative is 1 by 2 root x. It means this 1 by root x get eliminated by substituting what? Root x minus 1. See here I am substituting what? Put root x minus 1 is equals to t. So differentiate with respect to x. Derivative of root x is 1 divided by 2 root x minus derivative of 1 is 0 equal to t with respect to x is dt by dx. I hope all of you understanding. Now see here. Now after this we know that 1 by 2 root x minus 0 is 1 by 2 root x equal to another nodri dt by dx. dt by dx. Now see here, I substitute root x minus 1 here and remains in the question 1 by root x dx. What remains in the question? 1 by root x dx. Therefore, 2 shift towards right side and dx towards the left side. So it means we got 1 by root x into dx is equals to 2 into dt. I hope all of you understanding. Now by using this substitution, integral I is equals to integration of CL 1 divided by root x minus 1 is t into 1 by root x dx is what? 2 into dt. So 2 into dt. Again I equals to 2 is constant taken outside, integration of 1 by t dt. Therefore I is equals to 2 into integration of 1 by t is log t plus integral constant c. I hope all of you understanding. Again replace t by what? Root x minus 1. Therefore I is equals to, therefore I is equals to, see here, I is equals to 2 into log modulus t. What is t? T is root x minus 1 plus integral constant c, and this is a final answer for the given integral problem.